this example, we have an inclined plate with a known inclination angle to the vertical. Over the plate, water is flowing. Obviously, the direction is downwards. We know the inclination angle and we know depth of the water layer. Better at this point to define our coordinate system, x and y. And we are looking for the shear stress exerted by the plate on the water. It is not yet known, but the shear rate, shear stress, is equal to the applied force over the area of the surface. Now keep in mind that this area is for the hot plate, which is not obvious in this graph, this schematic. Another tricky point is that we are looking for the force exerted by the plate on the water, and this one is negative. Why? Because the water is applying a force on the plate along with the water flow, so the plate is applying a force on the water in the opposite direction. We can also assume that this force is attributed to the weight. At any given point, we can break the weight to the x and y components. And theta is again this angle. So now fx equals to bx equals to the mass of the water times acceleration of gravity. We can assume that the mass of the water equals the density of the water times the volume, which then is equal density times the depth of the layer times the area of the plate. Further on, okay, here I forgot cosine of theta. Now, if I combine these equations, we get that the shear stress equals minus density times delta times the area times cosine theta over the area. These two are cancelled, and then the shear stress equals minus density times the depth times cosine theta, and of course I forgot the acceleration of gravity up here. Now if I replace the known values, which in this case are theta, the angle, delta, the depth, 1/4 of an inch, and I convert it to the size system, and of course the density equals to 1000 kilos over cubic meter. Then substituting the values, I'm getting that the shear stress equals minus 1000 kilos over cubic meter times the depth times units times acceleration of gravity foci of 20 degrees. If I do the math, this one is equal to 58.5 kilos, forgot to count the units, square meter times square second. I can combine the units to Newton per meter. So this is it.